Yes. Thank you, guys. Uh, First, today is the last technology of the wired network, and next week we will have 3 days of the wireless technology, includes FAT AP, FIT AP, roaming, something like this. So today we will have three topics about the OSPF, ACL, and the NET. Of course, let's have a brief summary before we talk about the OSPF. Yesterday, we take a lot of time to talk about the direct and the static route, right? In our network, if we have layer 3 devices like the layer 3 switch, the router, maybe the firewall, and these devices will help us to follow the traffic between different segments. And the basic one, we have to let the devices know the routing table, because in the table we have lots of entries to help the devices how to follow the traffic, how to select the best path. And how to make the routing table full of the entry, we have three type of the root source. The first one is a direct. And about the direct routing, when you give the IP address of the interface, and of course your interface should be an active interface. That means you give the power, you give the link, and you can see the indicator is green. And then you give the correct IP address. Then the devices will get the direct routing. It's very easy. But if lots of devices are not directly connected with each other, we have to let the devices know besides your direct connected routing, there are also other routing information in your network. So the second way is we can manual it by myself, and this way we call it static. And when we configure the static, and we also have lots of parameters. According to the routing table entry, we have to configure the network address, the mask, the next hop, and the outer interface, and also the AD value, right? And all the different resources, different source of the routing, we will select according to the AD, the administrative distance, and we will select the best one and then add into the routing. And by default, the static routing, the AD value by default is 1. And when we compare to select the best path add into the routing, we have some parameters we have to compare. The first one is if we have two routes and they have the same network, same mask, but different next hop, and we will select the smallest AD and then add them into the routing table. And if the AD value is same, we will compare the metric. Also, the smallest value will be selected as the best one. If the metric also is same, and finally all the route will be added into the routing table. And this route we call is load balance, right? And we can use these multiple passes to provide the load balance function. Okay, so this is a principle. But after this step, you can think belong to the control plane working. And after we get the entry of the devices, then when the devices receive the metric from, we receive the packets from the terminal, maybe from the other devices, we only have one principle to do the forward. And the principle is longest subnet mask. That means we will take the destination IP address and use the mask in the routing table and find the longest destination matching and then forward out of the packet. And in this scenario, we don't consider about the AD value, and we also don't care about the metric. So this belongs to two plans, one for the control plan and another one for the forwarding plan. We have different principle. Okay, so this is direct and static. And in our network, if we visit the same destination and we have multiple next hop, and we can change different AD value to provide like the flow static route, right? And the two paths, we have different priority, and in our routing table, the smallest one will become the best one. If the next hop is broken, we can still use the backup one. This one we call is floating static. And the second one is we can use the same AD value to become the load balance. And the third one, we also can do some route aggregation by the static way and to shorten the number of the routing table in the devices. So we have lots of scenario to use the static. And in our network, if your network is simple and small, maybe add the direct and the static route is enough. And today our topic, the first one is OSPF. We see we have three source type of the routing table. The first one is direct routing, and the second one is static routing, and the third one is dynamic routing. And about the dynamic routing, we also have lots of different protocols, like the RAP, like the OSPF, ISIS, BGP, and so on. And today we will discuss something about the OSPF. How to work about the OSPF to get the correct routing information and let the devices can help the terminal or the host to follow the traffic successfully. Okay. And before we talk about the detail, I have one question for you. Do you deploy OSPF in your network or not? Do you use this protocol before? If you use the OSPF in your network before and you maintain, please write down one to let me know. Otherwise, please write down two to let me know it. Do you use OSPF before or not? No answer? If you use OSPF before, please write one to let me know it. One, yes. Okay. Three people say already use OSPF before. Yes. Okay, so if you deploy OSPF before, maybe when we talk about the principle and the configuration, if you have any question or suggestions, maybe you can write down or maybe you can open your microphone and then we can discuss together. And then let's say the first one of the OSPF. Okay. About the OSPF, the full name is Open Shortest Path First, and this belongs to the Link State Algorithm Protocol, and also usually used in the AS. So also we call OSPF is the IGP protocol, and this protocol is defined by one organization, and this organization we call is IETF, and also we have lots of other organizations in our network like IEEE, right? And why we use OSPF in our network? That's because OSPF have lots of advantage. Like when we use OSPF to calculate the route, there is no loop. But if you deploy the RAP in your network, maybe there will be a loop. But if you have loop in the layer 3 part, it's a little better when you have loop in the layer 2 network, because in your layer 2 network, if you have a loop, your network will be broken. And every device cannot work until the bandwidth is full, of the message. But about the layer 3, because we have one value of the IP header, we call it TTL, time to live. And when the message is sent out across one device, and the TTL value will be -1. And the biggest value will become 255. That means after cross more than 255 hops, finally the TTL value will become 0, and then the message will be discarded. So at this part, we say if layer 3 we have a loop, it's a little better than layer 2, but also we hope there is no loop, because finally the message cannot be forwarded to the destination, and this is a waste of our network. And after taking this course, we hope that the first one you can describe some basic feature of the OSPF. And the key point is we have to know how to the OSPF, about the OSPF, how to work. And yesterday we talked about the basic of the routing table. We call about dynamic routing protocols, main 4 steps to calculate the routing, right? The first one is to find the neighbor. So we also have to know what's the process of OSPF neighbor is shape established. This is the first one. And we found the neighbor. The second one is we have to exchange some routing information. And in the OSPF, this one we call is link LSA, the link station. Okay, the link station. And what's the detail of the LSA? We also have to know. And then the OSPF will calculate, will select all the LSA of the network, and then we'll build a LSDB, the link station, the link state database. And in this process, if your network is broadcast type, we have to select a special rule. One we call is DB, and another one we call is BDR. And about the DR and the BDR, sorry, there is a mistake. We have to select one is DR and another one is BDR. And with them, we will establish a special relationship. We call it adjacency. And finally, we can get the LSDB. And the next step is, according to the database, we will use a special algorithm to calculate the route. Okay, so they are main step of the OSPF. Of course, how to find the neighbor. Why I can send the message to find the neighbor information, and to do the negotiation and exchange some link state information. That's all because we add the configuration of the devices. We give the configuration of OSPF. So the last part, after taking this course, we hope some basic OSPF configuration you also can master. So these are the objective of this topic. And first, let's see some basic principle. How does the OSPF work? The first is the full name and what's the algorithms. We already know it, right? OSPF, open shortest path first, and belong to the IGP, and also use the algorithm is link station. And another parameter is the OSPF only propagates the routing information that is not available on the other end of devices, and the network convergence will be quickly and effectively avoid the wasting network resources. This one is very important. Also, this character is compared with the other dynamic protocol like the RIP. RIP will tell all the network if one link is broken, or maybe we add a new link. We will we will send the whole routing table to my neighbor. So if your routing table is big, in your link, in the certain time, you will send out every information. So this is a waste. But about the OSPF is different. I only send the message that you don't have. If you have it, I will not send again. So this is the advantage of OSPF. And another one, OSPF also can support VLSM, the different mask of the routing, and we can support the route summary, route aggregation to make your routing table shorter. And also we can provide some load balance function, and we can divide the network to become different areas. This is a zoning function. And also OSPF, we can add some authentication to keep that in your network. When you find your neighbor, and you can test the password and establish the legal relationship with the devices. So this also is a characteristic. And about the OSPF, how to find the neighbor, how to change the routing information, we will exchange some OSPF packets. And every packet in our network, we have to do the encapsulation successfully. About OSPF, the message is directly encapsulated into the IP layer, and we will use the IP header to help us to follow the traffic. Because we directly encapsulate into the IP layer, so we will use the protocol number 89 to indicate the OSPF protocol. And the next feature is OSPF, the default administrative distance is 110. This is the default value of the RGOS platform. Of course, we can use a command to change the AD value. And finally, for example, you hope OSPF, the route calculated by OSPF can be the best route. In this scenario, you can change the AD value to make the different result. And the last one is OSPF send out the protocol packets with multicast address. So if you use the Wireshark in your network to get some packets, you will find some multicast message from the OSPF. Of course, different. For example, in your network, maybe you deploy the BGP. BGP uses the unicast message in the neighbor relationship, but OSPF is multicast. But about the RIP, the RIP 1 version 1 use a broadcast message, but version 2 use a multicast message. So they are different detail of the different of these dynamic routing protocols. So this is OSPF function. And then let's see what's the work process of OSPF. The main stage of the OSPF is first step we have to find the neighbor relationship. We will send out some message of OSPF, and this message we call is hello packets. And after we found the neighbor, we want to establish the adjacency relationship. Pay attention, the neighbor relationship and adjacency relationship is different. The neighbor relationship will only exchange hello packets. Of course, in this hello packets, we will negotiate some parameters like the area, like the hello time, something like this. After negotiating successfully, we only will establish the adjacency with the DR and BDR. Only have the adjacency relationship, then we will send out the routing information. We call it a link station. Okay, so this is adjacency. And then we will transfer the link state information. And this is a key point why we found the neighbor, why we have to establish the adjacency. Because I want to share my link state with you, and I also want to know your part. And then we will build the database, and then we can calculate the route according to the database. Why the database is so important? In the database, you can know the whole topology in the network. What's the interface address, what's the mask, what's the cost value, and then each devices, they can use a special algorithm, we call it shortest path first, SPF algorithm, finally to calculate the best path and based on my devices. So this is the main 4 stages of the OSPF. And let's see the process. The first one, how to find the neighbor. We have to enable the OSPF. And about the enable, the first one, we have to enable the process OSPF in the devices. And the second one, we also have to enable the interface because the detailed message will be sent out through the interface. So we have to enable the interface of the OSPF. If no processing. That's why someone say I already use a command to create OSPF, but I cannot find any relationship with the other devices. You have to check that your interface enable OSPF or not. If yes, then the devices will send out the hello packets. And in the hello packets, we will have the default time to send out. For example, in the broadcast domain, every 10 seconds, I will send out the hello packets. And in the hello packets, we have lots of parameters. I will show my neighbor what's the area ID of my interface, and what's my IP address, what's my subnet mask, and I do the authentication or not. And if I add the authentication, what's the password? Something like this. And when my neighbor receive it, we will do the negotiation. For example, if your area ID is different with my site, we cannot establish the relationship. So this is one point we have to do the negotiation. And later, if we don't receive the hello packets, we have to wait. If you only can send out but cannot receive, you also don't have the relationship with the routers. But if you can receive it, then that means you can do the negotiation, and all the parameters you have to sync with your neighbor. Of course, some parameters should be different, like the router ID. And later I will explain for you what means router ID. And if the parameters is negotiated successfully, and we will have a data to show you, and this data we call is two-way. Okay, it's two-way. That means the neighbor relationship is ready now. And later, we will select the DR and BDR. DR, you can think this is the design router is a master, and the BDR is a backup master, like the backup router. And we also have to establish the next relationship, we call it adjacency. After established successfully, then we can send out the link state station. If in our network there is no DR or BDR, we also have to select at first. Or selected, or maybe selection complete, then we will establish the adjacency with the DR and the BDR. Why we need this DR and BDR? That's because we want to reduce the repeat information. For example, I have lots of devices in our network, and the information I send to everyone, if every two router to establish this relationship and exchanges the information, there's some information is complete, is repeat. So we want to select the DR and the BDR to indicate the router in the network, and then I will send everything to DR and BDR, and DR and BDR can get every information in the network and uniformly send the information to all the devices. So this is a reason of the DR and BDR. And after we establish successfully, and also we exchange the link state information, and we also will get a new status. This data we call is full. Of course, we can use the command to check what's the status. And finally, according to the link station, we will use the algorithm to calculate the route and add the route in our routing table. So this is the OSPF process, how to work. And the OSPF message is directly encapsulated into the IP header. And about the OSPF protocol message, we have two parts. One is OSPF header, and another one is OSPF detail message. And we have 5 types of message. Someone say OSPF is very complex. That's because we have 5 types of message. And although in one message, like the LSU, we will add a lot of LSA information, link state information. And the link state information, we also have different type. So someone will be say OSPF is too complex. So about the message, the first one is a hello packet. We will carry the parameters to establish and maintain neighbor relationship use this message. And the first one, we will send out the hello message to find the neighbor. And after we establish the relationship, we also use a hello message to maintain the relationship, because I have to detect my neighbor can work all the time or not. Otherwise, I will delete the information from my neighbor, because this will become the wrong information. So about the hello packets, we have 2 functions. First one, we have to find the neighbor. Second one, we have to maintain the relationship with the neighbor. And the second message is DBD, database description message. And this will carry the LSA header information, describe the LSDB to its neighbor. And pay attention. LSA is the detailed information in your network. This is not a package. This only you can see the message and be encapsulated into the OSPF application layer. And the LSA, we will have the detail like what's your IP address, what's your mask, what's your cost value, and something your network type, and something like this. And we will use this one to establish the topology. So these are detailed information. But in your DBD message, we only have the header. The header like the about this training, we have 12 topic, right? And one presentation is one LSA. But at the beginning, I send you about the timetable. I show you what's the topic of these 12 presentations. And this timetable we call is DBD. But each presentation, one presentation is one LSA. So in the DBD, we only have the summary information. And then after we found the relationship and we exchange the first parameter, first packet is a DBD. I will tell you what's the routing information in my network I have. And you also can send to me and we can compare. If I found something you have but I don't have, I will ask you to please send me the detail. And how to give the requirement, I will use a new package we call it LSR, link state request message. I will send out to ask you, please show me the detail of OSPF principle. And then I will use a new devices we call it update message LSU. And in this time, I will give you the OSPF presentation, not about the timetable. So in the LSU, we can carry the LSA to the neighbor about the topology information. And at the last, every part I receive from my neighbor about the LSU, I will give the acknowledgement to tell you the message you send me, I received successfully. But if I within the period time I don't receive the LSACK, that means the LSU message I sent to me, maybe because of the network, maybe because of the attacker, the packet is lost. So I will send you again. So these are 5 types of the OSPF. Of course, when we exchange different parameters in our network, the data will be different. And about the OSPF, the first one we say we have to find the relationship of the neighbor, right? And about the neighbor discovery, we can use the command to check the neighbor relationship. Like the command show IP OSPF neighbor, we can now find we have 2 neighbors and what's the neighbor name and what's the priority, what's the status, and the status, if the status is full, that means we have the adjacency relationship. And what's the neighbor rule of DR, BDR, or maybe DR other. This is a normal DR. And how to establish the how long time we establish the neighbor. Pay attention about the dead time. The default value is 40 seconds. Because about the hello packets, we will send out every 10 seconds. So if over 40 seconds I don't receive the hello message, I will find my neighbor is broken. So I will delete everything from this neighbor. And then is address. This is address of the neighbor, and this is interface on my side to connect with the neighbor. So this is a command to check the neighbor status. And how to find the neighbor, the main packet is a hello message. And when we find the neighbor, we will add every information in the neighbor table. Okay, we have the first table is the neighbor table. And then we will to establish the adjacency relationship with the neighbor. Of course, we say we only establish the adjacency with DR and BDR in order to announce the routing information. And after we exchange this routing information and finally the LSDB, the database is full, we will have a new status. This data we call as full status. And this also is a second table we call is LSDB, link state database. And in this process, we have lots of packets. The first one is DBD to send out the summary LSA information, and then if my site or maybe my neighbor lost something, we will use the LSR to get the request. Please send me the detail. And then I will give you a reply, LSU. LSU is a packet, and all the detail LSA will be encapsulated into the LSU message. And after we receive the detailed information, I will give you the acknowledgement, LSACK. So this is the process, how to establish the relationship of adjacency and how to announce the routing information. We also can use the command show IP OSPF database to see the detail, but you will find this is a little difficult to understand because this format is different with your routing table. We can have different LSA type like the router LSA, network LSA, and we have the area number, something like this. But about this topic, we don't analyze about the detail of LSA. If maybe in the future we have chance, we can discuss together. So this is a database, and you only need to know the function of database is to store the topology information in our network. The topology information is different with the routing information. Routing information means you have to determine the only destination and what's the best path. But in your topology, how to visit the destination, maybe you have multiple choice. Okay, so this is LSDB. And the third one, why we need the neighbor, why we need the LSDB in order to get the routing information. So we will use the SPF algorithm. This is an algorithm and can avoid the loop and calculate the routing information and add the OSPF route into your IP routing table. And finally, to be the best path to help the router to void the traffic out. And about the OSPF, the default AD is 110, right? But about OSPF, we also have different type internal of this protocol. We have 1, 2. Can we see the detail of OSPF detail? What means the detail information? What type of detail information do you want to know? Neighbor. You may show IP OSPF neighbor and you want to see more detailed information, right? I remember we have the command show IP OSPF neighbor versions. This one I have to check when we have the breaking time and later come back to you and give your feedback. The neighbor relationship and the neighbor detail. But I remember this one should be the detail enough, I think. Later I will check it. And about OSPF, we also have different priority in the protocol internal, like OIA, OE1, N1, or E2, N2, because about OSPF, we have different area. And O means the routing information in the same area. OIA means the routing come from different area, but the rest of two types, that means the routing from different AS. For example, you import some other protocols into the OSPF. So we also have different priority. And we can show the command show IP route, and in your routing table, you also can see the detailed information of the OSPF, the destination, the AD, the metric, and what's the next hop, and something like this. Of course, we also will have the OSPF table in our network. And in your OSPF table, you only can see the routing information calculated by the OSPF. But in your IP routing table, you can see lots of types. These two tables are different. And then let's see the detailed process, how to find the neighbor and what's the different status. In OSPF, the first one, you also have to use a cable with connect with the devices like the router and give the IP address of the interface. But the special one in OSPF is the router ID. And the router ID is very special, like the name of the router, right? So in the same AS, if you're running the OSPF protocol and each router, the router ID, the name should be unique. And how to give the router ID, how to select the router ID. Later I will talk the detail. We can select automatically from the different interface, or also you can use the command directly to give the router ID for devices. And at the beginning, if we only enable the OSPF protocol in the devices and not receive any hello packets from my neighbor, the state will become down. Here are the status for the neighbor. Okay, when you use the command display OSPF neighbor, you can see the status information. Because now I don't receive any hello packets. So in the neighbor table, there is empty and the status is done. And then I will send out the hello message. And in the message, I will send out my router ID. That's mean my name is 1.1.1. And now I don't know anyone in the network yet because I don't receive the hello packets. And in this time, if the route 2 receives this hello packets, I will add the route 1 information, your name, your neighbor, physical address in the table, and the status will be init. This is the first time I receive the hello packet. Of course, we will do the negotiation. I will check my name is conflict or not, and my area ID is in the same area or not. In one link, the area ID should be same. Okay, the area ID should be same. And the neighbor status is empty because when I receive the hello message and carry myself information, I will change the status to become full. Because this is the first hello packet from route 1, and route 1 doesn't add the route 2 information, so the status will become empty and to the init, but not about two-way. But in this time, if route 2 sends the hello message to route 1 and told route 1 my name is 2.2.2 and I saw 1.1.1.1 because I already received hello message from your site and also do the negotiation, the parameters is ready. So in this scenario, route 1 receives the message, I will change the neighbor relationship to become two-way. Our neighbor relationship is established successfully. So this is the first step to find the neighbor. About this part, any question for you? This is easy to understand, right? So about the neighbor discovered by the hello message, and we will record all the information from this message and send out the hello message every 10 seconds to establish the relationship and also maintain the neighbor relationship. And more than 40 seconds is considered as a failure because 40 seconds I already can receive 4 hello packets. Maybe their network is unstable, but I think if all packets, 4 packets are lost, I think my neighbor is broken. So I will delete the neighbor information. In the two-way status at this point and cannot change the link state information. So in this step, two-way, they will not begin to exchange the link station. And the next step, we want to exchange. And in this process, when we establish the neighbor, we have lots of parameters we have to know. The first one is router ID. And the router ID is uniquely identifies a router running the OSPF in the AS. And the AS we call is autonomous system. That means a system usually by the routers and using the same routing table. And AS, usually when you do the configuration of IGP protocol like OSPF, you maybe don't know what means AS because we don't do the configuration of AS. But when you do the configuration of BGP, the first step you have to create the AS. And each router must have a router ID. It's very important. And the router ID cannot be duplex within the same AS. And this ID can be selected automatically and also can be configured manually. So this is a router ID. And the second one is the neighbor relationship. And two routers running the OSPF protocol, and then they will send out the hello packets. And if the parameters we can negotiate successfully, we can establish the neighbor relationship. And we can check the neighbor information in your table. Okay, in your neighbor table, you can check the neighbor information. And the third one is adjacency. And the adjacency means we can exchange the link state information, but not the neighbor relationship must be the adjacency relationship. Maybe not. Depends on the network type, depends on your router rule. If your network type is point-to-point, for example, maybe you use a serial interface to connect with each other, and in one link, we only have two interfaces. And in this time, the neighbor relationship will become the adjacency. But if you use the broadcast network, for example, you use the Ethernet interface to connect with each other, and we at least to select the DR and the BDR, and finally the adjacency relationship only will be established between the with the DR and BDR. So if there are two routers and I'm run OSPF and my router ID is 10101, and then the other router also, when we send out the hello packets, will tell you what's my router ID. It's 2.2.2. And about the router ID, we say we can configure manually, use a command, or maybe we can select automatically. And if we don't add the command to give the IP to give the router ID, we have to know the principle why we finally choose this IP address to become the router ID. The format is same with the IP address. So if we select the router ID, we also will select the information from the interface. And the principle is, if in our network there is an active loopback interface, we will take the maximal value of the loopback interface. For example, like the left one of route 1. There are loopback 0 and 2 physical interface. And about the loopback interface, the characteristic is, first, this is a logical interface. The second one, we can give the configuration of subnet mask 32. Maybe you can try to give the subnet mask 32 of your physical interface. There is a warning to you, you cannot configure successfully. Okay, so if we have the loopback address, we will select the maximal IP address to become the router ID. And if we don't have the loopback address, we will take the maximum value of IP address among the active physical interface. Pay attention, only the active physical interface IP address can be selected as a router ID. So like the route 2, we have 3 physical interface, right? By default, we will select the maximum value of 192.168.3.1 to become the router ID. But if this link is broken, we will select the router ID to become 192.168.2.1. This IP address to become the router ID. But we suggest to configure the router ID manually, and you have to do the plan to keep that each router will have the unique router ID. So this is the first one. And the second one, in our network, how to establish the adjacency relationship, we have to select the DR and the BDR, right? Why we have to select the DR and the BDR? And pay attention, DR and BDR is selected based on the interface. What's mean based on the interface? If there is a router, route 1, route 2, and route 3. For example, 1, 2, and 3. Maybe about route 1, the first interface will be DR in this link, but the second interface maybe will become BDR in this link. So not means we select one DR in the area or maybe in the AS. We only select one link, one segment, one DR and one BDR. The other segment we also have to select. Of course, in your network, you have the broadcast network. That means you use the Ethernet interface to connect with each other. Because in the Ethernet interface, you can deploy a switch here and connect with multiple routers. If we have lots of routers in one segment, like this topology, 1, 2, 3, 4, 5, 6, right? And about this router in the same segment, if each two routers establish the adjacency relationship, here at least 15 pairs of adjacency. But if we maintain the adjacency relationship, we also need the resources. So if we select the DR and the BDR, finally we only establish the relationship with DR and BDR is enough. So there are only 9 pairs of adjacency relationship. Okay. Of course, if in the segment you only have 2 routers, maybe one is DR, maybe another one is BDR, they only have 1 pair of the adjacency relationship. But if in the segment over 2 routers, select the DR and BDR, the relationship will be better, will be reduced. And how to select DR and BDR, we also have the principle. The principle is, first we will compare the priority of the router interface, and the higher priority will become the DR, and the next one will become the BDR. And the range is from 0 to 255. I remember the default value is 1. If we use the command to make the priority to become 0, that means this router will never become DR and BDR. This will become the normal router. Normal router we call is DR others. Okay, is DR others. And another one is, for example, like there's lots of router and we give different priority. Their priority is 1, this priority is 2, and the one is priority 3 and priority 2. Finally, these 4 routers, these 4 left routers will become, right router will become DR other. And the priority 3 will become DR, and the priority 2 will become BDR. And how to change the priority? We can use the command IP OSPF priority 10. And pay attention, this command will be added into the interface. If you use a layer 3 switch to running the OSPF, maybe you can enter the VLAN, SVI interface to give the priority. If there is a layer 3 interface, you have to enter the interface and to change the priority to become different value. And another one, in case of the same priority, the one with the highest router will become the DR, and the second highest router will become BTR. And once the DR and the BDR is selected, if the DR and the BDR can work, although maybe we add a new devices with higher priority, this one also cannot be a DR and BDR. And when we can have the chance to become DR or BDR, if DR is not working, BDR to become a new DR, and then we have to select a new BDR. And then maybe if the DR is broken again, the highest priority can be a new DR. So in a sentence means if we select DR and BDR, we have to keep the network stable. So if we also have the highest higher devices with priority, this one also can be the DR other. So here is an example for you. we have route 1, route 2, and route 3, and route 4. If we don't give the command to change the priority, the default value is the priority 1. So if the priority is same, we will compare the route ID. The highest priority, the highest route ID will become the DR, and the second IP address will become the BDR. So according to the principle 1, 2, 3, and 4, who will become the DR? Can you show me the answer? 1, 2, 3, 4. In this segment, if we don't change the priority, who will become the DR? Can you show me the answer? Yes, route 4. Route 4 is a DR, and route 3 will become the BDR. But in these scenarios, route 1 and route 2 will become DR other. And in the network, if we select all the rules, who is DR, who is BDR, and then we add a new devices, route 5. And about route 5, the route ID is 192.168.5.1. So can you show me the answer? What's the rule of the route 5? DR, BDR, or the other? What's the rule of route 5? Yes, this one should be the DR other, right? So this is the principle in order to keep the network stability, okay? And if the DR is broken, we will select the BDR to become a new DR. And the rest of routers, according to the principle, we will select the highest priority to become a new BDR. This time, route 5 will become BDR. And if route 3 is broken again, route 5 will become DR. Of course, if the route 4 is recovered, route 4 also only can be the DR other in order to the stable reason. So this is an example. And then we will know, we already use the hello packets to select to establish the neighbor relationship. And we know we have to establish the adjacency relationship with DR and BDR. And we also know how to select the DR and BDR, right? And the next step, if everything is ready, how to begin to exchange the link station. This is the main second step. And when we exchange the link station, the first message we call is DBD, database description message. And when we send out the DBD, the state also will be changed from two-way to X-start. And then the DBD will send out, I started exchanging information because my route ID is 101.1. But route 2 also will send out the DBD. I started the exchanging information first because my route ID is higher than yours. So the first one we say in the DBD, we have the summary LSA information, right? Like the timetable of the training. I will show you in my network, in my database, what's the segment I have. So you can compare. And as the first, before we send the summary information, we have to decide each message of the OSPF, we need the sequence number to keep the network transmission is security and reliable. So what's the sequence number we have to use? We will compare the DBD message on the route ID. The higher route ID will become the master, and I will use the sequence number according to the master. So about route 1 and route 2, the route ID is higher than route 1. And later, the route 2 will begin to send out the date message. X start to become exchange and send out the database. And in the database message, now we will begin to carry the summary information of the link state database. And route 1 receive it and also will send out the database from my site. And in this sequence number, we will listen and we will decide from the route 2. Okay, so this step from the first database, We only to select who is master, who is slave, and use which sequence number. And about this database, we will begin to carry the summary information. Okay, so this is a DBD message. And the question here, of course, when you enable the OSPF configuration, they will exchange automatically. Send out the database also about the hello packets. And then after we receive the summary from my neighbor site, and I will compare with my database. And then if I found that I have some information, but I don't have. So I will send the message of LSR, and I need your complete information, your detailed information of 172.116.10.0 message. And then the route 2 will give a reply. Please show me here as a detailed information. Also, the status will be different, will become loading. And if in the two routers, route 1 and route 2, the information is saved and the database is full, the status will become full. Finally, I also will give the acknowledgement to you. I already received your LSU packets and I can get all the information. So this is the process how to build the LSDB. And in the process, the detailed information is get the LSA, the link state information. And in the LSA, we have lots of information. We have the IP address, we have the mask, and we also have the cost value. And the cost value, how to calculate? Because about OSPF, finally, when we calculate the message, when we calculate the path, we want to select the best path. And about the metric of OSPF is the bandwidth. And we will select the cost value smallest, the highest bandwidth value, finally to become the best path. So how to calculate the cost value? We have the format. The cost value is default calculation base and division the physical link bandwidth, and the default calculation base is 100 Mbps. That means if your data link, your bandwidth is 100 Mbps, finally the cost value will become 1. And if your bandwidth is 10 Mbps, the cost value will become 10. So if we compare these two paths, we will select the 100 Mbps to become the best path. So this is a formula how to get the cost value. And there is a decimal result. We say 100 Mbps, the cost value will become 1, right? If your bandwidth is 1 gigabit, the cost value also will become 1. That means the smallest cost value is 1. Okay, and as we know, if we have the path of 100 Mbps and 1 gigabit Mbps, 1 gigabit Bps, so we want to select the 1 gigabit link, right? And how to let the OSPF know that 1 gigabit is better? We have two solutions. One, we can directly to change the default calculation base 100 Mbps to become bigger. For example, to become 1000. So the result of 100 M will become 10, but 1000 M, the result cost value will become 1. So we will select the 1000 Mbps. Okay, and how to use the command? We say option 1, we can change the default calculation base, and the command is this one. Router OSPF 10. This is the command to enable the OSPF process in the router. 10 is a process ID, and you can change the auto cost reference bandwidth to become 1000. And if you change this one, pay attention, all the interface in your network, you enable the OSPF, the cost value will be changed. So in this topology, we will select the blue one, because the blue one, according to the default cost value, the cost is 1, 1, and 1. But this link, the cost value is 10. So we will select the cost value smallest as the best one. Okay. And the second option, we can directly under the interface and change this cost value to become bigger or smaller. For example, the command is this: enter the interface and change the IP cost value to become 200. So only this physical interface will change the cost value to become 200, and the rest of the interface, we only use the default base calculation base 100 Mbps to calculate the cost. So the result will become 100 divided 1000 is the result will become 111, but this interface we use the command to become 200. So we also will select the blue one. Okay, we have different influence of the range of OSPF. Pay attention about this part. Change the cost value. And then after we get the link state and to build the LSDB, and finally we will use the SPF algorithm to calculate the best path. Of course, this calculation also will be done automatically. If you want to control some paths, for example, to select the blue one as the best one, you have to change the cost value and then to finally to influence the calculation of the SPF algorithm. Otherwise, all the topology will be automatically calculation by the same algorithm. Okay, and after we get the LSDB and finally the state will become full, we say now your network synchronization successfully, and the LSDB is same in the same area. And the database in the same area, we will have the same database in different devices. Okay, so this one we have to know. The LSDB must be same for OSPF routers in the same area. Route 1 have the LSDB, and finally, according to the LSDB, we will get the routing information of OSPF 10.1.0.0 and 10.2.0.0. And how about the cost value? Pay attention about this part. We will add all out interface cost value to become the last cost one. If route 1 calculate to the network 1, and if we select the best path is the red one, this only is an example. The cost value is physical interface, add physical interface, add physical interface, and finally is your physical interface. And if the message come back, if route 1 here, we also have the same segment. And about this router, how to calculate the cost value, we will have this link, and this out interface to become the cost value. And pay attention about this, the other part. One link, the bandwidth will be same, right? The speed is same, but the cost value can be different because we can use a command to change the cost value. Okay, so maybe in the result, you will find according to different plan, route 1 to visit the network A, the best path is the red one. But maybe you change the cost value. When the message reply to route 1, we will select this path as the best path. Okay, so this also we can see some load balance because we use different traffic and across different paths. So this is the calculation. And we say we will select DR and BDR. Pay attention, DR and BDR only will be selected in the multicast broadcast network. For example, in this network, we have 3 links and connect with a hub, maybe connect with a switch, and all the interface in the same segment. So this network we call is broadcast network, and we have to select one DR and one BDR, and the rest of them will become DR other. If in your network you can keep that only one link between 2 devices. Also, maybe you use the Ethernet interface to connect with each other. In this scenario, maybe you can use a command to change the network type to become P2P. If we select P2P, we use the P2P. We never need to select the DR and BDR again. So this one also can help us to converge the network faster because we skip some process. And another one is a single region problem. If all the router in the same network, in the same area, and each router, we say in the same area, the LSDB should be same. That means if route 1 have 100 LSA and route 2 also need to have 100 LSA, but maybe in your network differently as a performance is different, right? So if all the router in the same area, we have some problem like excessive consumption of resources and the performance will degradation because the LSDB is same. If one link is broken, we have to send out the LSU and LSACK to advertise everyone. You have to update your LSDB. You have to use the algorithm to calculate a new path again, something like this. So everyone have to do this work. But maybe in your data center or maybe in some bigger network, about your router, you also divided like the edge router, like the core router, like some distributed router, something like this. And the performance maybe is different. So this is the first one. And the second one, I will have received too many LSA notifications. And the other question, maybe the routing table I need to maintain is too big. Because more routing table, more LSA maintains, you need more resources, you need higher performance. And last one, maybe frequent SPF calculation. So how to solve this problem? We have some solution for OSPF. It's divided into different area. And after we divided the network to become like this one, 5 areas. And we can control LSA to flood only in the region. And between different region, we can use a new LSA to indicate this information. But the detail part is less than the first LSA. So this is the first one. And the second one, we can improve the network stability and scalability. What's the meaning? For example, if in this area, one link is broken, and this area, all the router have to know the detailed information. But for this area, this router doesn't need to know, right? Because if the network also exists, I only know my next hop is this router is enough. And this router will forward to this router. And maybe this router will know the detail of the result. And finally to forward to the destination. But this router doesn't need to know the whole topology. Okay, so this is the we can improve the network stability and the scalability. And we also can do the route aggregation in different area devices. And we can reduce the number of routing table. That's why in the bigger network, we will use multiple areas. But pay attention, if you create more areas, the technology will be complex and you need to know more information of OSPF. So this is a little difficult to maintain. And we only can send some first LSA within the area, but between different area, we can use the other LSA. That's why we say OSPF also is very complex because of this part. If you only have one area, the configuration is easy, and the type of LSDB is easy, but for the devices, it's not friendly. But if you divided multiple areas, for the lower performance devices, it's good. But for the engineer, for an administrator, you have to master more principle of the OSPF. And about the OSPF, if we have multiple areas, we also divided the area to become different levels. We will divide the area to become backbone and non-backbone. each area we will have the area ID, and the backbone area means your area ID is 0, and the backbone area cannot logically be divided. Okay, like this area to become area 0, and the rest ID of the area is non-backbone area. All area other than area 0 will become non-backbone, and the non-backbone area must connected to backbone area. Maybe you can physically connect it, maybe you can logically connect it, use some technology. And each area we will have the area number, like area 1, area 2, area 3, and also area 10.1.1.1. Because when you do the configuration to create area 3, the result will become area 0.0.0.3. Okay, so this is different areas. And after we divided the different area, we will make a different rule of the router. Like here we have area 1, area 0, and area 2, right? And the first one is IR, internal area network, a router. All the interface in the same area. This one we will call IR, like this router. And another one we call is ABR, area border router. And we divided the area based on the border. That means one router may be different interface belong to different area. Okay, and about the ABR is very important. That means this router at least belong 2 or more than 2 areas, and at least one interface should be area 0. And ABR will maintain the LSDB of each region by they are connected, like this ABR. We have at least 2 LSDB, one for area 1 and another one for area 0. And the inter-area routing information must be passed through the ABR. If area 1, we have the segment 10.1.1.1, and if area 2, the router want to visit this segment, this router must have routing information, right? So the router must to forward it to ABR 1, and the ABR also have to forward to ABR 2, and the ABR to send this router. Then we can get the router information. And another one for this router, we call it as backbone router. Backbone router means all the interface belong to area 0. And another router we call is ASBR. ASBR is auto system border router. The router, if we connect with multiple protocols, like the right one, connect with the OSPF, and also maybe we use the RAP protocol, and we import some RAP protocol into OSPF and send to the neighbor. So this router we call is ASBR. Okay. And the next part is a configuration, because we talk about lots of concepts. Then let's see the configuration. In the first one, if we only have single area, all the router located in the same area, and the requirement is we have to configure OSPF, and there are 3 routers, and to give the process ID is 10, because there is a single area, and we let all the router belong to area 0, and finally we hope PC 1, 2, and 3 can communicate with each other. So this is our requirement. And the first step, of course, you have to use a cable to connect with each other, and you have to give the IP address. And the second step, you have to add the OSPF configuration. How to create the OSPF process? The key command is router OSPF and give the process ID. And this process ID is the optional configuration. That means if you don't add the process ID, it doesn't matter. We have the default process ID is 1. And how to enable the interface to running OSPF? The command is network and give the network mask, and then to give the area ID. Like the route 1, about route 1, we have 1, 2, 3, 3 interface, right? First, to create a router OSPF, and the process ID is 10. And you have to network 192.60.2.254. And here, this is the weird mask. 000 means we only enable this IP address and make this interface to become area 0. And another one, 3 segments, right? This interface, why we have to enable to become OSPF message, that's because we have to send out hello packets on this interface to establish the relationship with the R2. Why we have to enable these two interface? That's because only you enable this interface, then the segment information will become the LSA, add into the LSU packets, and then send to your neighbor. So you will know the information. If you don't enable this link or this link, maybe route 1 can have OSPF neighbor successfully, but route 2 cannot learning the segment of PC1 and PC2. So this is a key point. Of course, the mask 000 indicates you only enable one interface. This is the interface of route 1. And about route 2, same we only enable the interface connect with route 1 and the interface connect with route 2. The same configuration of route 3. But pay attention here. Because all of us belong to the area 0, so here you configure area 0 is enough. In the same link, if route 1 physical interface and route 2 physical interface, the area ID is different. They cannot establish the relationship. So pay attention about this part. But the post ID, it doesn't matter. For example, route 1, you use the post ID to become 5. Route 2, you use the post ID is 10. It doesn't matter because when I send out the hello message, I don't add the post ID. So the post ID is used for locally. So this is a basic one. And you can use the command show IP routing table to check about route 1, except 3 direct routes. We also can get the segment of 10.2.0.0 and 192.160.1.0, right? One segment for this link, one segment for this link. So we can automatically learn to get the segment information except the direct route. And about the route 2, we will have 3 service segments from route 1 and route 3. And about route 3, we also have the service segment from route 1 and also one link belongs to route 1 and route 2. This is a single area. And we can use the command on PC1 and PC2 to ping PC3, and we can find the result ping successfully. And also, here we can see some status information. Show IP protocols. You can see all the protocol information. The first one is OSPF. OSPF 10 is the router ID. And you will find the outing update filtering and the incoming update filtering is not configured. Because on OSPF, we also can add some filtering command to filter some routing information. This is my router ID. And this information as part of OSPF. Number of areas in this router is one, only one normal router. And the routing information for network, we have 2 second network from area 0. And the reference bandwidth unit is 100 Mbps. And the distance is 110. And about the route 2, you also can see the OSPF neighbor information. What's the neighbor ID, priority, and status, something like this. And when you see the IP OSPF interface, then you can see the interface enable OSPF and some detailed information. The first 2 parts is the basic physical information of the interface. And here are the information of the OSPF. You can see which process you use, what's the router ID, what's the network type, is broadcast or P2P, and what's the transfer time delay, and how many hello packets you receive, something like this. So you can see the detailed message of the OSPF in the physical interface. And the default hello time is 10. The data time is 40. 40 data time means 40 seconds later, if I don't receive the hello packets, I will directly delete the neighbor. This is a single failure. And the second one is multi-area. You have at least 2 areas. So the requirement also, we create the process ID to become 10, and we hope the PC1 and the PC2 and the PC3, they can communicate with each other. But the different one is now we have 2 areas. The right one to become area 0, the left one to become area 1. And then the configuration also is very easy, but different one is route 1, all the interface belong to area 1. Route 2, one interface belong to area 1 and another interface belong to area 0. And about the route 3 is area 0, but the other configuration is same. But if you configure 2 interface changed one by one on the route 2, they cannot establish the neighbor, they cannot get root successfully. So this is multi-area. And after configuration, you can see this show IP routing, and you also can see all the segment, but the different one is the characteristic. Now we cannot get the value of O, but the value will become OIA. Because area 1 gets the segment of route 3 and the link between route 2 and route 3 by area 0, by the other areas. So the value will become OIA. The same of route 2 is route 3, because route 1 and route 3 are located in different area. But about route 2, the value still will become O, because route 2 have 2 areas. We have 2 LSDB. So this is different to indicate what's the source of the OSPF protocol. And of course, if you have the segment and you use a pin to test the connection, this one also is successful. And here is a question for you. The OSPF administrative distance of Azure OS platform. What's the default administrative distance? Can you show me the answer? A, right? And what's the protocol encapsulation of OSPF? What's the protocol number of OSPF if we want to do the encapsulation? The protocol number should be 89. This is option B, right? The default AD value is A. So this will become A. The second one, what is the default OSPF overhead for an interface with a physical link bandwidth of 50 Mbps? What's the result? What's the result of the option of the second question? Do you know this one? Yes, should be B, right? We have to use 100 divide 50 by default, right? So the result is 2, B. And option 3, which of following statement is false? Which are false? This answer should be
Oh, sorry. B, C, and D, right? This is a multi-choice. The first device priority is priority of DI and BDI. The default value is 1. The second one was false. Any router can do the summarization? No. Pay attention. But this part we don't talk about on the topology. On the presentation, only ABR and ASBR can do the route summarization, and the configuration is different. So I only explain about the option B, okay? Not every OSPF router can do the route aggregation. Only ABR and ASBR can do. That's because they can create a different type of LSA. And what's the mistake of option C? OSPF gives preference to the IP with the largest physical IP address as a router ID. Pay attention about this part. First, we will consider about the largest loopback address. If no, we will select the largest physical IP address, but this IP address should be active interface. So C also is wrong. Option D, the router ID of two routers in the same OSPF area cannot be same. They must be unique, right? So this answer is option B, C, and D. So about this part, we talk about the OSPF. This is a dynamic routing protocol, and the default AD is 110, and the protocol number is 89. And we have 3 tables: neighbor table, and the database, and the routing table. And between the devices, how to select what's the status from at the beginning there are no status, at last the status is full. And in the broadcast domain, in the broadcast network type, we have to select DR and BDR, and how to select what's the principal. And also we can divide the OSPF to become single and multiple area. Depends on your requirement, because divide multiple area, we can control the area, can do some route aggregation, something like this. So that's all about the OSPF part. Do you have any questions here? OSPF maybe is the most complex topic in this training of wireless technology. And we only talk about the basic of OSPF, but we still have lots of characteristics of OSPF. If no, maybe we can have a break time now and come back 15 minutes later, and we can continue to talk about next topic.